In late 2023, when India's Chandrayaan-3 rover touched down near the moon's south pole, few in the West expected it to shake lunar science to its foundations. But what it discovered has stunned NASA, ESA, and space researchers across the globe. Signs of a long-lost molten ocean. Strange moonquakes near the pole. Elements that suggest not just water, but the potential for future life-supporting habitats. This wasn't just a routine mission. It opened a new chapter in lunar history. Tonight on Midnight Mindset, we explore Chandrayaan-3's dark revelation, the secrets it unearthed that may change everything we thought we knew about the moon. July 2023, the Indian Space Research Organization launched Chandrayaan-3 aboard an LVM-3 rocket. Unlike its predecessor, this mission was built with one goal: land safely at the moon's unexplored South Pole. On August 23rd, the Vikram lander made history, gently touching down at 69 degrees south latitude, a region previously untouched by any nation. It marked India as the first country to reach the lunar South Pole, and only the fourth to land on the moon. The stakes were high. NASA had plans to explore this same region under its Artemis missions. They say Russia and China were watching closely, but Chandrayaan-3 got there first. The South Pole is not just another cratered region. It's home to permanently shadowed areas that haven't seen sunlight in billions of years. Scientists believe these dark craters may trap ice, possibly some of the oldest water in the solar system. With the Pragyan rover on board, equipped with cutting-edge instruments, Chandrayaan-3 was ready to begin its slow, careful crawl into the unknown. In the mission's first few days, Pragyan analyzed over 100 meters of the lunar surface. What it found validated a long-standing but unproven theory: that the moon was once covered in a global magma ocean. The rover's instruments, particularly the alpha particle X-ray spectrometer APXS, detected high concentrations of ferrone anorthosite, mineral believed to have formed as the moon's early lava ocean cooled and crystallized until now. Most of these samples came from Apollo missions near the moon's equator. Finding the same mineral near the South Pole confirms that the magma ocean covered the entire moon. It's not just one region. This changes everything. It suggests the moon cooled uniformly, and its internal structure may be far more stable and consistent than previously believed. That has huge implications for future missions hoping to drill deep into lunar crust. One of the mission's most surprising finds was the presence of sulphur. This is the first time sulphur has been detected on the moon's surface, inside too, by any mission. Sulphur is a volatile element, meaning it can vaporize easily, especially in the extreme heat of the moon. Its presence near the surface suggests a history of volcanic activity or trapped chemical reactions within the regolith. Why is this important? Because sulphur is often found alongside water ice and volcanic regions on Earth. The detection could mean more than just geology, could be the key to identifying water reserves trapped beneath the soil. For future lunar colonies, this is gold. Sulfur can be used in building materials like lunar concrete, and possibly even in chemical fuel production. The moon may not just be a rock, it might be a resource. Then came the tremors. Chandrayaan-3's ILSA instrument for lunar seismic activity recorded over 250 seismic events. During its brief operational window, shockingly, nearly 50 of them were not linked to rover activity. These were internal tremors, moonquakes coming from within. The South Pole was thought to be geologically dead. Apollo missions had detected seismic activity near the equator, but none this far south. Could this mean the moon's core is still active? Or is something else causing these tremors? Meteorite impacts, thermal cracking, or deeper mystery under the lunar crust? The fact that these moonquakes occurred in a region so far from known tectonic boundaries has puzzled scientists. And unlike Earth, the moon has no atmosphere to cushion seismic energy. Even small shifts can travel far, echoing beneath the surface. What is the moon trying to say? Another unexpected revelation came from Chandrayaan-3's chased instrument designed to measure thermal conductivity near the surface. The probe discovered a dramatic temperature gradient, while the surface baked under +60 degrees Celsius. Just 8 centimeters beneath, the temperature dropped to -10 degrees Celsius. This steep difference in temperature over such a short depth shocked scientists. It suggests that the lunar regolith moon's dusty soil acts as an excellent thermal insulator. Why does this matter? Because future lunar habitats may not need expensive external protection. A few feet of moon dust might be enough to shield astronauts from both extreme heat and cosmic radiation. In terms of colonization, that's a game changer. Nature may have already provided the perfect blanket. Asterisk, among the many minerals detected by Progyon, one stood out: olivine. Olivine is typically found deep within planetary mantles, including Earth's. Its presence near the surface of the moon suggests one thing: material from the moon's interior was blasted up and preserved, likely by the massive South Pole Light Cone Basin impact billions of years ago. This basin, one of the largest known impact craters in the solar system, may have punched straight through the lunar crust. That's why minerals like olivine and magnesium-rich compounds, normally buried deep, were found just lying in the regolith. This find offers an unprecedented look at what lies beneath. It's like seeing the moon's skeleton exposed. After Chandrayaan 3's revelations, attention quickly shifted. Western scientists, initially skeptical, began reanalyzing old data from Apollo and Lunar reconnaissance orbiter missions. Suddenly, South Pole was no longer a cold, lifeless region. It was a treasure trove. NASA's Artemis program accelerated development of its Lunar Gateway plans. ESA announced intentions to collaborate with India on shared missions. Even commercial space companies began redrawing their lunar maps. India, once an outsider in the space race, had changed the trajectory of lunar exploration, forcing every major player to take notice. And as Western headlines cautiously praised the mission, one message was clear: the moon had secrets. And Chandrayaan 3 had just cracked the first page open. Asterisk, despite its brief lifespan, Chandrayaan 3 left us with more questions than answers. What exactly caused those unexplained moonquakes? Could sulphur deposits point to more widespread subsurface ice? How deep does that ancient magma ocean layer go? Are there lava tubes or hidden caverns that we haven't yet found? The data is still being analyzed, and future missions, both robotic and manned, will chase these answers. NASA's Artemis 3, China's Change 7, and India's proposed Chandrayaan 4 may provide deeper clarity. But one thing is certain: this quiet little rover has reignited humanity's obsession with our nearest cosmic neighbor. The moon is no longer a silent witness to Earth's history. It's a living archive of the solar system's earliest days and possibly a stepping stone to Mars and beyond. Chandrayaan-3 was never meant to last long, but its findings will echo for decades. Here at Midnight Mindset, we believe that curiosity shapes civilization. And tonight, we've seen that even the quietest missions can change the loudest conversations. If you found this story as intriguing as we did, hit the like button, subscribe, and share this with someone who loves the mysteries of space. Drop a comment: which discovery shocked you most? Moonquakes, ancient magma, or buried ice? Stay curious, stay grounded, keep your mind in orbit. This is Midnight Mindset.